Hey, what's up, folks? Welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit, and joining me every week is my brother Pedro.
Good morning, everybody. Pedro is Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring hidden electronics from Adafruit.
Silvery electronics. We'll talk about what's behind this and why in just a few moments. We want to welcome everyone to the show. We are live streaming, and if you'd like to join us throughout the live stream, you can do so by hitting up some comments in the Discord chat room. We're hanging out in the Discord chat room, the live broadcast channel. Is that what it's still called?
Yeah.
Live broadcast chat is the official name.
Good
So we're gonna take some
morning, good afternoon, good
welcome
evening.
everybody.
And good night to everybody hanging out all over the world. Shout outs to Rosin, Andy Calloway, Dew Wester, Charles Beneford, Stuart Riggs,
I'm trying to get
Mike
coffee.
P, Vince, Cup of Coffee,
Cup of coffee.
Green Apple Pie, Rolves.
I need my emoji chat thing again.
We're also hanging out in the Facebook chat
I'm
on
trying, folks.
Twitch.
I'm doing my best. I don't know if you can see floating windows. That's my emojis to you. Coffee, lightning bolt, lightning bolt, lightning bolt. Yeah, so let's run through the housekeeping. We'll try to get through it. We got a lot to talk about on this week's project. So first up, I'm just going to tell everybody about the freebies going on. If you order stuff with Adafruit, you'll get some free stuff depending on how much monies you spend. So for orders that are $99 or more, you're going to get a free half-size Parrot Proto. For orders that are $149 or more, you'll get that free half-size Parrot Proto plus a Stemma QT breakout. If you have an account with Adafruit, we'll make sure you don't get the same one twice. And if you order things that are $200 or more, you'll get the Stemma QT breakout, the half-size Parrot Proto, and free ground shipping from the U.S. continental. Free ground shipping from UPS for continental US only. You can get as many freebies as you want. They get automatically added to your cart, so no need for any special coupons or anything like that. They just happen auto-magically. We got a newsletter that happens once a week. That's called the new newsletter. And you can subscribe to that by hitting up adafruit.com/newsletter. If you'd like some daily newsletters, you can go to adafruitdaily.com and see all the various categories. Our favorite one being the Python and microcontrollers newsletter, headed up by Amberella, sometimes PT as well. But shout out to everybody for subscribing and sharing their stories. Please continue to do so. You can hit up Amberella on the Discord chat room if you want to get your project featured in the weekly newsletter. Heading on over to the jobs board at jobs.adafruit.com, you can find out all the latest gigs that are available. And if you are a maker or an employer, you can create your profile or you can create your listing. I'm taking a look at it this week. We have a new position, looks like from Evil Mad Scientist in Sunnyvale, California. There's some great folks over there. They're looking for a manufacturing assistant and some multiple openings. So if you are in the market for a new gig, check out the many great positions at jobs.adafruit.com.
They are awesome. What
Yeah.
did we have? We had like Hot Pot or something with them?
I actually clicked on them. I'm actually interested in part-time fabrication. I got a friend that's looking for something. So, yeah. Very cool. They even have all the description looks very lovely. So check that out if you are in the market for a gig for some special folks. All right. And that is the housekeeping this week. We'll jump back over to the Discord chat room and catch any banters, gifts. Anybody got any gifts?
Good morning, everybody.
I got gifts for you today. I have 2 gifts that I want to share.
And he's scared that Lars might be hiding behind the screen.
That would be
ready
really,
to jump
that would
out.
be really flippin' awesome if he took
Wow,
over the
gotcha.
show. Hello. That'd be really funny. We should chat with John so we can make that a thing. Special guest Lars. He does a layer by layer. That'd be great.
A Lars by Lars.
A Lars by Lars. Lars by Lars. Yes.
All right, let's go ahead and jump into this week's awesome project.
I'm not quite ready yet. Give me a second here. You got your links and things?
Yep, all the links are in.
All right, when your prototype goes in, I'm going to hit the reorder button and we're going to get our stuff situated. All right, this week's project, I think we're ready for it. All right, folks, this week's project is a fun collab project with Liz Clark. If you go head on over to learn.adafruit.com, you can find out the latest guide here is our Party Parrot Zoetrope. So this takes the idea of a Zoetrope and makes it a little bit different. It uses edge-lit acrylic and some 3D printed parts. And the CRICKIT, the Adafruit CRICKIT Featherwing with the Feather M4 to make a pretty cool Zoetrope. So what is a Zoetrope? Zoetrope was invented like 1830s. It's a very old way of displaying animation in a physical medium. So the you go to the wiki Zoetrope, which I can do for you. Just give you a quick history lesson on Zoetropes. 1830s. It was a printed sheet of paper, and there is a sort of a barrel with slits, and the idea is that you look through the slits and it creates the illusion. Once it's in motion, when it's spinning, you get the illusion of animation because the frames are spread across the strip, and when it's wrapped around in the cylindrical drum, it gives you the illusion that the frame is spinning, kind of like how a camera works. So this was before camera, before cartoons, before animation. This was the way to do animation, and it became a bit of a thing. Folks would make their own, and companies like Milton Bradley started manufacturing it in the early or the late 1800s, and you can DIY your own. We actually have some in the Learn system of some more traditional Zoetropes. You can see John, this is probably kind of the first ones I remember seeing, is one from John Park. This one here, where he also used the CRICKIT and a DC motor to do this. Dano also did a papery one.
Oh yeah.
Yeah, this one was really cool. You can actually print this out right now. So if you got the kiddos, a really cool way to showcase animation in the physical space, taking out and then just understanding how, you know, how this effect works and how you can construct your own with paper. So really, really cool. Also uses the CRICKIT because it's so easy to get motors and lights and sensors connected to your project, and that's why it's using the CRICKIT, because we think the CRICKIT is just the best way to do it. You could do it with other things, but we really like the CRICKIT because you got so much capability from the board. So that's a quick little Zoetrope thing. Another thing I wanted to share was this YouTube video. This was actually the Zoetrope prints from Milton Bradley in 1866. So we're looking at gifts from 1866, folks. That's really, really cool. So these were printed out on strips of paper, and they were available along with this sort of Zoetrope thing. So it's kind of cool to see this. Cool thing about the Zoetrope is you can have color and do things like that. So where did I get the idea to make the Zoetrope? It kind of started with the a couple projects ago. We did a acrylic lamp, and the acrylic lamp had I think 6 panels of acrylic, and the NeoPixel animation would just step through them. So when it's doing this LED chase animation, it almost looks like there's an animated effect. So it got me thinking, like, what if we could make that move, turn that on make a 3D printed carousel, and then have these basically the same acrylic casing, but in a circular thing. So I figured, like, how do I drive it? How am I going to do it? So I figured to 3D print the gears and make it so that there is a gear inside that rotates the cover. How's our audio? Is it okay? Okay. So it's kind of a combination of a bunch of different ideas. Why a party parrot? Me and Liz have done a couple different party parrot projects, and I just had the vector graphics already. So to convert those graphics to be engraved or laser cut or CNC milled wasn't that hard. It was actually kind of easy because of I already had the graphics for each frame, and the party parrot frame is only 10 frames of animation, so it wasn't too much to trace it by hand, so that's kind of why the party parrot, because we kind of already did it. And so let's kind of walk through the Learn guide, or no, I should probably do an actual thing. So we got it set up here, and because of the lighting situation and the way edge lit acrylic works, you get a lot of reflections from cameras. So one of the hardest things is to get this to kind of look good in the lighting. So let me turn it on. This is a demo. Okay. It kind of sounds like a parrot too. Let's see if I can get the... I think if we turn this light off, you can get it to really pop out. All right, so it really depends on how much lighting you got. So if you want to make this in an installation or something, I would kind of set up in a similar way where the lighting is very much controlled, and if you're trying to film it, it's even harder because you're going to get reflections. So like without this reflector here, you just get a lot of illumination that you might not want. So that's why I have it set up this way. All right, so what else can I talk about it? Let me turn it off for a second, and I'll kind of try to showcase the thing. So the top comes off, right? And the way this works is that there are slots rather, on this bottom cover, and each panel is just press fitted into these tabs. Okay, so then the main base of it has the three components, right? So the three components is the motor in the middle, and in the center, and it has this 3D printed little bit here. So this is 3D printed gear. I'm going to ask...
You have to project your voice this way.
You're right. I'm just going to bring everything over there because that's not going to work. So you saw the demo. Cool. Let's actually show the assembly. I'm going to need you to move that. Thank you. All right. So here is the top cover. Now the top cover is modular in the sense that, let's say I want to do a 20 frame animation. Well, you would just print out this one piece. So there's 3 pieces here. You have this encoder ring that has these notches. And the notches is what tells the photo interrupter sensor. It's basically an IR LED in this T-slot format. So if you ever seen our hula hoop project that had an IR LED, it can track when things pass through it. This can track when things pass through it. So I have it mounted on the side here because the LED is mounted right there, and whenever something passes there, it will be able to change the NeoPixel. So if I fit this in here, you can kind of see the photo interrupter doing its thing there. So you can see as it's spinning, it's able to know when is the beam open, right there, when it's actually on a frame, and when is the beam closed, when it's not on a frame. So that's how the mechanism for telling which frame, which color to be is working. So it's like that. And it's spinning freely right now because I took off the gear, which is right here. But when the gear is there, you won't be able to freely spin it because the motor has, you know, the way the motor works, you don't want to strip it. So that's why I have it. So this thing is just printed. This is a herringbone gear or something. Yeah, I forgot. But it's able to print without any supports. And I used a plugin in Fusion 360 to generate this. Yeah, so the way it's able to turn is like this inner ring has this channel, right? That's all it is. I've actually added some lubricant inside the channel. So this prints out with any supports. And what you can see is there's some little arcs here. And these semicircles allow the wiring to just kind of pass through. So it's a really, really simple construction. Good amount of screws to secure everything down. You can see that this motor has 2 shafts. I had to trim that down just so it was kind of flush with this. So you just want one thing there. Yeah, so the T-slot interrupter is right here, mounted here. That way it can track the encoder ring. And the NeoPixel had to be mounted inside of the framing because that's kind of how it works, right? It needs to be able to shine the light just through this, so that's why everything else is kind of blacked out. And when it passes over the NeoPixel, it's able to illuminate the acrylic. So kind of like how the slits are through your traditional Zoetrope, my slits are down here because it allows the light to pass through, and that's what allows you to see it, which is pretty cool. Now another thing that I want to do is this internal gear, I didn't want it to be a part of the top because let's say I want to make a 20 frame thing, then I'd be printing the gear over and over again. So what I ended up doing is making this gear actually pop out, so it's a press fit thing, and that's kind of neat. So I made the tolerances on these tabs very, very tight. So I don't even want to take them out, to be honest, because they're so well in there. You don't want to break them. So, but just to kind of show some cleverness here, I figured that since I'm engraving these, I'm going to lose track of what frame it is. So the way that I've designed it is that there's this tab on the bottom of this panel, and that tab has space. So what could you do with it? Well, let's add a number, a frame number, so you know exactly what frame you're on, so you'll never forget. Another thing is that the tab used to be in the center when I first tried this project out, and that looked okay, but I wanted to kind of position it so that the frames are a little bit more out, because as I started to decrease the diameter of the main assembly, this panel would start going on the inside, and you just kind of want to adjust it so that you have spacing. So when it's in motion, this kind of flares out a little bit outside of the thing. Yeah, so there you can see the slot. If you are making this, my tolerances are really tight, so I recommend filing this down a little bit. But I really wanted these to like not fall out, and I didn't want to glue them for obvious reasons. But it should be like that. And the encoder ring. So it's a 3-piece thing here. You got your inner gear ring, you got your top cover, and then your encoder ring. So if I wanted to make a 20-frame animation, I could just update the value from 10 to 20 in Fusion 360 and print out this one piece, and then I can reuse my encoder ring and my gear, because those take a minute to print. So it's kind of modular in that sense. And this comes right off of the main thing here. Yeah, so let's talk about the CRICKIT. The CRICKIT is running CircuitPython. The CRICKIT comes in different flavors. This one is for the feathers. So the Adafruit Feather M4 is what's kind of the brains of it. And the CRICKIT just gives your feather the capability to drive motors, separate motors, capacitive touch, a drive thing, motors, a speaker, a NeoPixel, everything you kind of need to make this sort of really cool art installation. So you wanted to add sound effects to it. You wanted to add capacitive touch pads so that folks can control this. So you can go crazy with this and use every little bit of the CRICKIT. But we figured just 3 things that we're using. We're able to use the photo interrupter, which is an IR LED. We have the NeoPixel LED, which is over here. And then we have the motor, which is just power and ground. But you can reverse it and stuff. But yeah, this is a little 3D printed bumper for the Feather, or for any CRICKIT really, because they're kind of the same, other than the Raspberry Pi one. And there's a built-in on-off switch. What's really cool about the Feather is you just give it 5 volts, 2 amps from a power supply with this barrel jack, and it powers all the things, and the Feather, and the CRICKIT all in one go, which is really cool. Yeah. And yeah, running CircuitPython, which we'll take a look at, code by Liz. So take a look at that. Oh boy, what else is we got here? I guess I'll put this back together. If you got yourself a laser cutter and you'd want to make it, I would say that's really cool, because the laser cutter is a great tool for doing this this many panels. If you're doing a CNC mill, well, you know. So this just press fits in, stays like that. And the way to get this in to the top, you kind of want to get the encoder ring through the slot first, right? And then you can start to feel your way towards the center thingy. There it goes. And then just make sure your gears are engaged, and you're good to go. Try not to move it too much, because you'll strip the motor, which I have done many times. So yeah, this is it. It's about 180 millimeters in diameter. So you'll need a 3D printer that can have about that. They take several hours to print, so you're looking at a pretty hefty build time. But and it scaled up to a person, like how big it is. You could try to put this all in together, but I really like it separate like that, so all the wiring comes out through this cover. So the cover has these openings for the hole to route through. So you can see like this wire here has 4 wired connections for the sensor, and I have a little hole that you can barely see there, and then there's the main hole there, just to get these wires out. But you could integrate it into a single unit if you wanted to do that, but I figure folks probably want to use a different microcontroller, so I'd rather not integrate this assembly to specific PCB or whatever, right? You could run this off a 9-volt battery if you wanted to, if you just wanted the light in there. But yeah, we like the
smarts behind it.
Smarts behind using a encoder ring to tell what frame you're on.
Really quick question from Vince asking, generally speaking, how durable are the 3D printed gears?
I don't know yet, but that's a great question. For something like this, it made a lot of sense, because like this is about 200 grams in weight, so there's not a lot. How much weight?
I think you mean by like the teeth, them being engaged. Are they gonna like melt if like it's going too fast? Like,
from my experience so far, no, they're not gonna melt unless you kick it really, really fast. I don't know what the RPMs are, but I guess we could write code to track the RPMs because that's kind of how the demo code for this product is. But yeah, I would be wary if you are pushing more than a few pounds.
yeah, I don't see.
But this is
any...
like barely a pound. This is like I said, 220 grams of weight. I don't know how many ounces that is, but maybe it's like about half a pound in the Freedom units. But yeah, I have another project where I'm using a similar system, and really I got this this kind of geared system like this. I was inspired by a fellow who, his name is Isaac, and he made a 3D printed camera slider which used the similar type of herringbone gears, and he's pushing 5 pounds with his 3D printed gears with no backlash. Looks really good. So that's the only other place I've seen it and got inspired from to use this gear system. But that was a great question. Yeah, like how is it durably wise? For something like this, it's great. And I think if you're doing like 5 pounds or something like Isaac was with his camera slider, should be good too. If you remember a couple months ago, I think it's been a couple months now, we were working on a camera slider with a similar gear system, and it seems to be working pretty good. We'll revisit that in the summer, I believe. But great question, yeah.
I was thinking more of wear and tear, and so far we're not
Not
as
a
you're
single
saying,
wear
we're
and
not
tear,
we're not pushing it.
Yeah,
like the weight
because
limit
of the
these.
weight is like there's like very little friction. Like when I added the lubricant here, this is the only surface area that's touching. None of this surface area is touching the lip. It's on purpose. So the only friction you are getting is right here in this groove and right here on this lip. That's the only friction you're getting. Because the lip is big enough where this surface does not touch any of these surfaces. Does that make sense?
Yeah. Sounds like the major load and speed are the more of the factors.
Yeah. And the
wear
gear
and
is
tear.
mounted with these screws here. And there he goes. Yeah. The motor is mounted with these 2 long screws, so the motor's not going anywhere. Yeah. Do you want to see it running here? Should I do that?
That's fine. Let's go ahead and jump
that's
into the guide.
Cool. All right, let's jump into the guide. That's where all the magic is. Most of the parts are in stock. If you want to get the CRICKIT, you can sign up to get notified when it's in stock. But if you have one, that's awesome. We got the motors, but all you really need is the CRICKIT, a feather, the T-slot photo interrupter, the motor, and a little NeoPixel. These come in a pack of 5. These little PCB NeoPixels are really, really great for these type of projects. And the power supply. I really like this power supply because it's got a little potentiometer right under. You can adjust the voltage, and it can go from 3 to 24 volts, 2 amps. So that's my favorite power supply. There's some screws. I had to link some external screws to McMaster-Carr. To mount the motor, you need at least 30 millimeter long screws, which is fairly large. You're gonna have to buy those somewhere. We don't sell them, but we do have M3 kits, but unfortunately it doesn't include a long 30 millimeter screw. The sheets of acrylic are nothing special. You could get some special acrylic that has like special coating to make it really, really pop. It comes engraving. I get my stuff from Inventables.com. They are the folks that make the CNC mill. And you can get it from wherever, but this is where I get it. I get a 24 by 24 inches. As long as it's an 1/8 inch, it should work here. I did experiment with a 1/4 inch. You could do that too, but 1/8 inch is nice because you don't have to spend hours and hours milling it. So that's it, yeah. I don't know how many you'll need exactly, depending on the size. So I just put 4. You might as well get 4 sheets if you're getting small. But as long as it's an 1/8 inch thick, you're good to go with this one. All right, so those are all the parts. Let's look at the circuit diagram. Shout out to Liz for putting together the circuit diagram. We have fritzing parts if you want to create your own lovely wiring diagrams. Adafruit makes custom parts for fritzing. It's open source software. You can pay for it or compile it yourself. But yeah, that's how our wiring diagrams are made. Nice visual way to kind of reference how all the wire connections are. They are pins on the side of the photo interrupter that has these labels. In Fritzing, it's a little bit different, so that's why we put labels there. So that's good. And yeah, it's really nice to just be able to plug things in through screw block terminals. You do have to do a little bit of soldering because some of the things like the NeoPixel doesn't have wired stuff on it. But yeah, I like the modularity of the CRICKIT where you can just screw things in and plug things in. Yeah, and then for powering, again, just a note, we're using the power supply, the adjustable one. All right, onto the CAD files. All this was created in Fusion 360, but we have a step file so folks can use Blender or OpenCAD. This is FreeCAD? Folks, do you use FreeCAD? Can you let me know if you can import step files? I will search after the show, but I figured I'd just ask now. The STLs are available to download if you just want to print them as is. They're all oriented to print as is. No support material required for any of them? Yeah? Yeah. You might want a brim or two on some of the thinner things like the framing of the cover. But yeah, those are all the parts. There's a good amount of parts. There's about 10 parts. Okay. But yeah, STLs are available in the CAD source as a step file or Fusion 360. The CAD assembly. I figured I'd put this little CAD exposure to show all the pieces fitting together. This is fun, just watching it. Makes a good GIF. I spec order, but just to reiterate, you will need a printer with a minimum build volume of 180 by 180 by about 100 millimeters. So if your printer is too small, you could try to redesign it. In Fusion, it'd be easier, I think. But anyway, that's the minimum build volume. So, yeah. Now the panels, right? So the panels, deciding how big I wanted them, it really came down to the minimum build volume of my CNC mill. If I had a laser cutter, I would use a laser cutter. Don't have one, but I do have a mill. And the mill is kind of small. It's about 4x5. So these panels are 70 by 80 millimeters. That's about 2.76 inches by about 3 inches. So they're kind of small. You saw them in my hands. They're not that big. But they are SVG files, so they're vector graphics. They're scalable, and for laser cutters and CNC mills, I think that's the format that you want to use. Yeah, and I also have it here in the Learn Guide. It says the acrylic panel dimensions, and you can figure out how if you can if you can cut them out all in one go, try to do that. If you're on a mill and you have a small bed, you're gonna have to do one at a time like I did. But yeah, I didn't cover that much because I think this is definitely better for laser cutting. So yeah, that's the CAD stuff. Next page just walks you through installing CircuitPython on your M4. The CRICKIT's just ready to go, so you don't have to update that or anything if it's a newer CRICKIT. So just install CircuitPython on your Feather. And then here's the code. Shout out to Liz for putting it together. So yeah, this is all documented. You can see how we set up the different colors. So each color is put in a list here. So we have 10 of them because there's 10 panels. And then we have an array just to store all those frames in another list so that we can run through them in the loop. You can change the speed of the motor if you want to go slower or faster. It's just kind of hard coded. So right now I have it 0.3. You can crank it up to 1 and get it really going fast if you want the Parrot to just go into super mode. If you want a more slower Parrot, 0.3 is pretty good. But yeah, you can change around the colors and add or remove frames as you want. So yeah, check it out. It's CircuitPython, so it's really easy to kind of change it up, break it, and fix it again, right? But Liz did a great job explaining all the things and how it's exactly working. The wiring, you are going to have to wire some of the components because they don't come wired, like the NeoPixel. You just got 3 connections on the bottom of the NeoPixel PCB, button PCB. They're pads, so you can daisy chain them if you want to do it. But we're just using 1 pixel because that's all you need. And where you can use your jumper cables so that you can just plug those into the NeoPixel screw block terminals on the CRICKIT. Now the motor comes pre-wired, which is awesome. But the wire is kind of short, and if you want to kind of have your your Cricket detached from your assembly like I do, you can just plug in an extension cable, which I have linked here. I have extension jumper cables. They were here. They're probably in the other page. But yeah, you can just connect those in. Really easy to use jumper wires for that. Though this photointerrupter has 4 leads on the body of the sensor itself. Are labels positive, negative, L, and out. We walk you through that. All right, on to the assembly. I start off by modifying the motor shaft. You only need 1 shaft. This motor comes with 2. It's some not soft plastic, but it's malleable plastic. So I just use flush snips to cut off the end. And you can see here in the photo, you can have a little bit left. And you want to cut the shaft that has a little nubby bit. The other side is smooth and doesn't have a nub. So that's why I have my motor on that side. Okay. And then the NeoPixel has a special little holder. It has holes in it so that you can thread the cabling through it. And then the top has a little bit of a recess so that the NeoPixel button can just press fit in there. So there's no need for any glue or any screws to actually secure the NeoPixel to the holder. The holder itself does need screws, which we'll cover. But yeah, that's just getting those components ready in their holders. T-slot interrupter has lovely mounting tabs. It's really, really great. So I made this little kind of mounting thing that has cap screws. So you put the hex nuts through the 3D printed standoffs, and then M3 screws on top, and that secures the sensor to the holder. Really nice. All right, and then securing the NeoPixel holder to the bottom plate, just two screws and hex nuts. Make sure that the cable is kind of pointing inwards, because you kind of want your cables all routing through one thing in the end. 2 long screws for the motor and some hex nuts. Pretty easy to figure out what orientation they go. There's a center hole that allows clearance for the modified shaft of the motor that we cut off and trimmed. Yeah, just making sure that the orientation is correct. All right, so we have our 3 things mounted onto the inner ring. More screws, gets fitted in the center. Make sure that the wires are all routing through those little cutouts that I was showing. Putting together the top cover, you have 3 pieces. You have the outer encoder ring. Just make sure that the notches are lined up with the slots for the acrylic. I'm using 5 screws and hex nuts to secure it down. I cut it with glue, but boy, do I hate using glue. I always get my fingers glued. Even with gloves, I still... All right, and then getting the inner gear installed into the top cover. There's some notches and this little groove. You just line them up, press fit them. Tolerances should work out. The panels, once you cut them up, I don't really cover cutting them because whatever tool you want to use. Yeah, but the tabs really worked out really nice. Like the tolerances for them are nice and tight. So you can go counterclockwise or clockwise, doesn't matter, as long as they're chronologically, the animation works forwards, backwards, inverted, upside down, like it works always, as long as there's a sequence of them in one order or the other. Cool. The framing just snap fits into the bottom cover because there's a little kind of recessed groove, and you just kind of line up where your cables are. And yeah, what else? I showed you, it's a little bit hard to show in photos how to install the top cover because you have to get the encoder ring through the T-slot, the sensor. So that's why I showed folks. You just got to make sure that it kind of inserts at an angle. That's pretty much it, right? You start, you can use some screws to secure the CRICKIT board to the bumper. Pretty and then connecting everything together again, just plug and play. Just plug things in. The jumpers just plug right into the header pins and the screw block terminals here. So just make sure everything works and plug it in with the barrel jack, and it should just start working. There's an on-off switch built into the CRICKIT, so just make sure it's on. And yeah, that's it. That's the guide in a nutshell.
Ooh.
Yeah. Woo.
This is an excellent starting base for anybody trying to do any sort of entertainment with this. A little escape room or any visual effects.
Yeah, I'm
Halloween.
Sure. Yeah, that'd be cool.
Very
Yeah,
nice.
it's got this kind of, you can scale it up. Think about acrylic, edge-lit acrylic, and yeah, I really think the CRICKIT is an awesome little board to do these type of projects where you are sensing, driving, and tracking. So that's kind of cool. I haven't done a CRICKIT project in a while, but it was really nice to just plug things in and get a quick prototype going. Originally, we were just going to do just on white LED, and then it was like, I think it might be kind of cool if you could change up the colors and tell which frame it's on. And she did a great job writing the code to make that work in CircuitPython.
Yeah, great for like museums. Duester is mentioning that putting a Circuit Playground blue fruit on there had some sensors, so like when somebody walks in the room or temperature changes or something, cool. You can have different animations going on.
Right. It'd be cool to have proximity where as you are going closer, it is speeding up the animation or slowing it down. You have control over speed as well. Speed
that's right.
Converts into the, how fast is your animation going, which is pretty cool.
Sounds like interactivity for, again, like an escape room or something in a museum.
It's almost like it's like reacting to you, which is really, really neat.
Yeah, cool.
This is just, the beginning of something I think that folks can really take away.
Excellent little base.
Yeah. I also want to give a shout out to the 3D Zoetrope project by Kevin Holm. He, a couple of years, in 2018, he had a really cool Maker Faire project where he brought it to Maker Faire, won lots of awards, and it was like the first time a Zoetrope had 3D printed elements to it. And then I don't know if that predates the Disney Pixar Zoetrope. That's another famous one. Just talking about zoetropes. Like I started researching zoetropes. I'm saying it wrong. Zoetropes.
Yeah.
Or is it Noe-tropes?
Connor McCarter is saying that they'll check out FreeCAD to see what they can import when they get home.
Yeah, I will too.
General questions.
I need to know. What does my stuff look like when I import it into FreeCAD? Yeah. I'm seeing a lot of folks using FreeCAD and Blender. And, you're using Blender, so maybe I'll import a step file and see what it looks like. What is our structure, what does our component structure look like?
Real quick, just general question from Foamy Guy, who's asking, do we have any resources or talks about what printers we use, recommend for other folks? We do not. I just did a quick search on Learn, and some of the topics that we cover are pretty, not printer specific, so that's just doing a quick search. Yeah. Like how to print NinjaFlex, how to DIY filament, how to use dual extrusion.
Yeah, there's some other great channels out there, like all the
here's why we have not. We gave away 20 printers.
Donated.
Was it donated 20 printers a couple years ago?
Sure.
Was it?
Yeah.
I forget when. It was to Bill Binko, so he was able to give them out to schools and stuff.
Yeah, the robotics.
But all those printers, we gave them away because all those printer companies are no longer around.
Well, that's not the reason why.
well, we can't focus on one printer because it might not be here tomorrow or next year or whatever. So it's like a printer bot. Let's look at LulzBot. Let's look at MakerBot. All those models. We can't focus on any one model because it'll be gone by a couple years or whatever. So I just linked to the top ones that we like right now are the Cruelties. So I linked to the CR10 V3. That's our one of the go-to ones.
Sure,
of the Cruelties that we use. It's direct drive. It has you can get all these customized options from Tiny Machines, and they receive their shipments in from China. They inspect every single printer. They CNC mill custom parts for it. They do custom firmware for it to make sure things like your thermal runaway is actually working. Yeah. So definitely check out their printer or the printers that they have for resale. So the CR3 V3, it's like $650. Very nice, good deal for a top-notch, reliable printer, and it's backed up here by Paul Cutler saying that. They have the Ender.
Did you see Chuck posted on Twitter? There's $200 at what was the store?
Micro Center with the
was
coupon.
It Micro Center? Or
yeah,
was
I've seen people in
Costco or something like that,
somewhere.
like a big box store, and they had just a pallet of Enders. And I was
I saw them forget which. So Facebook
it's cool to
group.
see them in big box stores like that, especially
they were
Ender
out.
because that's kind of the same. It's Cruelty. They make the cheap.
Affordable
printers. I don't want to call them cheap because they're good quality.
They're all metal. All the parts are metal. There's nothing 3D printed, so or even injection molded plastic.
So there's lots of community support for these Enders and CR10s and things. So that's
And
kind
the
of why
reason
we
I
went that
say-
way too. We're kind of watching the industry, and everybody's going this way. So we got our own some, and we have experience with them, and they're pretty good. So
The user says that his buddy's got CR10 solid.
yay! I'm glad they work out.
Ender Pro, another shout out to Ender Pro from Due Wester. The reason why I mentioned metal and injection molded is because some other companies are still 3D printing their parts, and
Yeah, if it works,
there's
it's fine.
challenges.
It might, yeah.
I wouldn't pay a top dollar for something that's I want a metal parts that aren't gonna fall apart or like get all bent out or like heat hitting it, like the sun hitting it, or something like that.
Cool. Those are all good,
another
good
one,
options.
Ender 3 V2. Horror stories with it being shipped. Yeah, that's why I say tiny machines, because
they're US distributed. If you're in the States,
they're in Texas, and it ships like
they
immediately
QA
the same
it pretty
day.
good. Yeah, they QA
Yep,
it
something's
very well.
busted.
Custom firmware.
They have all the parts there to mill
We are
them
now
custom.
working for them because we sell their printer now. I mean, what you want to continue? Let's go.
No, that's it. Everybody, I'm just everybody in the chat room is chiming in on their experiences with it, and yeah.
I'm glad everyone's got good experiences with them. All right, so that's this week's project. Again, huge shout out to Liz for collaborating with this project. It's really magical. We can come up with fun artistic ideas, and
we were
hopefully
looking right before the
story is
show.
inspirational to folks.
Right before the show, we were looking at some Kickstarter ones, and it was like all this
I
crazy,
mentioned it. Yeah, I
like
mentioned the
CNC.
3D
It's
one.
like, oh my god, that's
Yeah, it's a kit. You can buy it if you want.
Yeah, this is I
I
think,
hope
a lot
this
more easier.
is a cool, to contribute to the history of animation in a physical form. I think it's kind of cool. 3D printing and acrylic and some NeoPixels.
All right, sweet. Let's go ahead and jump into this week's. What are we prototyping?
Sure, we'll come back to some comments and things as we go. But Paige has got a fun prototype, and I'm going to order some burgers.
So lots of Floppy going on, and Lamar requested some 3D printed cases for the 5 1/4 and the 3.5 inch drive. So tried my best on trying to get these as translucent as I could, because that seems to be the hot thing now with the translucent cases that they're showing off. One of the things that I wanted to make sure that the 3D printing was able to, or wanted to add that you can do with 3D printing, is getting all those cool shapes in here. Something I don't think you can do with either having the molded acrylic, like how they're getting. So, I mean, I guess you could do it by like laser etching it on there, but this is all in one go. You got your like ventilation on there. And the one thing I know you can't do is have these stackable little parts on top. So that's one of the things that she was requesting. So we're able to stack the 3.5 inch drive right on top of there. And we have the same translucent green on there.
That looks so good. Yay,
Right?
look at that.
So we have this translucent green. You can kind of see that. I wish this metal case wasn't here so you could see.
You can't tell if it's embossed or debossed. Like, I can't tell.
Oh, yeah.
Like, is it extruded or,
Yeah, you can, of course, with the lighting, it definitely brings out like the 3D printing layer
super
lines.
cool.
But in real life, it looks more like that, where you can see the translucency behind it. You can really see it on the back of this guy here. You can see like the mechanisms moving. Let me try to get the light angle good on there.
You can see the mechanism.
Yeah, so that's super cool that you're able to see the inside of that. If I get a little bit closer, you can kind of see the all the chips that are inside there. Look so cool with the looks like a little city or something. So this just slides in and slides out. You can see all the components on the inside there. So it is 1.5 millimeters thick, and that's the smallest that I could get it to be a little bit translucent without being where it'll just fall apart. It's basically kind of like a vase mode, manual vase mode, without actually using the settings from that. Yeah, lots of cool little detail that you can add on the side there. Didn't add as much on this one because it is going to be covered up when you have the drive stacked on top. But yeah, super cool that you're able to get some nice translucent effects with this filament.
Look at that transparency.
No, I know there's like some other
or any of that kind of fancy post production.
That's what I was about to mention. Yeah, that you could.
The serial and all that. Like, it works really well.
Yeah, it's super translucent, and again,
flexible it is, folks.
It's as thin as I could get it without it falling apart.
Is one perimeter? No, 2.
It's 3.
It's 3?
Yeah, 3 perimeters.
Just a regular nozzle, 0.4 stock.
Yeah. And it
Super
takes
cool.
that's I don't know. think it's like 11 hours to print the big guy, about 6 hours to print that guy. But yeah, we're using the geometric patterns inside of Fusion 360 to create the lovely little Adafruit logo there. But yeah, was trying to go for that. Oh my god, I forget what year the color IMAX came out.
Probably 98, 95, 98.
I don't know.
I think 98.
My son keeps referring to anything old as that's so 1990s.
Yeah,
so that's stuck in my head.
1990s.
Is it from the 90s?
No.
It probably was.
Oh, the actual IMAX.
The IMAC one. You know,
Yeah,
remember they had it like in circles
Yeah,
with all
power
colors. And
too.
like,
That's pretty cool.
comes in colors everywhere.
Mm-hmm.
But yeah, nice little simple project to keep your floppy drives nice and safe. I wanted to add like some mounts for the upcoming hardware that Lamar is designing to be able to interface with these and CircuitPython. So I'll add that on as those boards are released. I'll figure out somewhere to mount these so the board can be mounted on here like all nicely and enclosed. Duester saying, yeah, the glass bed. Oh no, something else. I was gonna say, yeah, I did try the glass bed. This is printed completely vertical, so this prints up with no supports. I did try printing it flat, but because I didn't want to like glue all of the sides together, I was like, eh.
No, I like it
and
all
it
in one
didn't.
piece.
It
really
wasn't as translucent as I wanted it to be, so went with this route, all vertical, and yeah, I'm still super impressed. I wonder how translucent it would be with that that
really,
coating
really
on
big,
it.
print.
But I think I'm happy with having some sort of opaqueness to it, so you can like kind of see what it is.
Do you know the filament name? People tend to
So
does it have a name?
it's like Zyro
No
something.
name
Yeah,
Most
again
filament is like that from Amazon.
Yeah, again, that's the other thing why we don't
link to filaments.
Filaments because
Well,
it could be here today but gone tomorrow.
Sometimes.
It's a weird spot, the 3D printing, like with filament in general. Like the Quantum, I'm able to link to that because I think they'll be around for a while.
Yeah,
but then you see
great.
like it looks like it's a white label. You see other companies coming
like
out with their
J3D,
yeah. So who knows? But yeah, nice little
PLA generic.
Yeah, but nice little way to add that classic Mac look. I was gonna show off like in CAD like how to create these, but unfortunately,
we will next week. We'll
it's
talk about
a paid for plugin that I just lost access to today. My trial expired today, so
pay up or shut up.
Yep, I will probably redo this with the manual way to do it. So have like the shape that I'm using to create the pattern. I'll have it in there just so you can manually do the patternization for that, which I did have to do with that Warble with the little glowy thing that I was showing off last week. So yep, that is what I'm prototyping. Nice little way.
Heard of the emboss toy?
Nice little way to just have a stackable set of your old school floppy disk drives with some cool translucency.
What's old is new again.
Yeah, just need some drives now and maybe a way to actually
some drives.
Power this. I mean, discs,
discs.
Diskettes. Yeah, super cool.
Yeah.
Gotta show it off in the.
I have
you don't
floppy
see
story. Maybe next week. I'll tell you my floppy story.
All right, that's what's prototyping.
Cool. That is what we're prototyping.
Nice little throwback to some retro tech.
Retro tech in the works. Retro adventures.
All right, jumping into the comments real quick.
What is enable dictation? Why would I want enable dictation? Why would you tell me that during the show?
DOS 3.3, says Andy.
We kind of did shop talk. I guess we'll take some comments.
Yeah, that's what I was doing.
I want to take Tim's Foamy guy.
He's had good experience with his Lulzbot Mini for years, but it's having some auto bed living issues. Yeah, and that's the other thing too. Sometimes the components start to wear out, and it's like, oh no, they don't have that available anymore. You're experiencing this with the CNC mill right now. Like they don't have those motors anymore. So
yeah, it's very painful when you got a machine that outlives the company or outlives the model, and you're kind of
especially with the supply.
You look at something else.
Strain how stuff is now. The cruelties, it's all of the third-party parts. All those are like made for all those type of machines. So you always get like some way to
Their design
rebuild
is
it.
very modular too, where you can just
That's the
add
key.
things to the
Exactly.
rails, to the extrusions.
Mm-hmm.
Yeah.
And then Duester giving a shout out to the glass bed, one of the best upgrades he's done.
You like the glass bed? We used to love it too, the glass bed.
I mean, we used it on the Ultimaker. It works
Yeah,
perfect
well,
there.
That's all we got, really.
Yeah. So both
you get
both
really
work
nice
well.
glossy finishes on glass,
Mm-hmm.
which can enhance your project, or depending on what look
It just
you want.
depends, yeah.
Yeah, sometimes like you'll get reflections that you don't want.
Mm-hmm. All right, cool. Let's go ahead and jump
Excellent.
into this week's community makes.
All right. Yesterday was a lovely. Monday.
Was it Monday?
I think it was.
Oh yeah, it was. Yeah, that's when we being
So
Brandy for Valentine's, went to friggin' Epcot and got popcorn buckets. That was our Valentine's. So this is a really cool way if you have an actual gift that'll fit inside, like a ring or something. This is a flower box. This looks fantastic. Oh my gosh, this was all modeled in Fusion 360, and it's a flower that hides a box component on the bottom, big enough to fit a little Lego Adabot, or of course a ring. That's what it's probably meant for.
Looks like he used some special filament.
Yeah, I did link
Matter
it.
Hackers. It's
I
called
did link it.
quantum filament.
And as you can see on the bottom here, you do get some little bit of leaking with that filament. Like tends to twist around inside the extruder. But other than that, you get a very nice.
Reminds me of spiral graph or something.
I mean,
tie dye or something fun.
flowers
Looks
do
really
have
cool.
this shape sometimes, so
Yeah.
it's kind of like true to nature in that sense.
Cool. So it's all 3D printed without supports, I hope.
Yeah, this is all prints out without
That's
supports, just the way that it's all 45-degree angle, so you see all the little
They just
petals.
snap into each other. They don't really click or anything. Oh, that's cool rotating.
Oh yeah, this just goes right on top.
You got your own Zoetrope there.
Oh yeah, you do.
Again,
It's kind of like a zoetrope.
Zoetrope.
You can kind of see the effect with the quantum filament when
That's a
you
good
spin
spin.
it, right? On the inside, blam, Adabot.
That's a great little.
And then nice little the way that the vine on the bottom, or the stem is supposed to be, it just clicks in there like that, and an
It just
excellent
It
just rests on there.
which is nice.
Well, when my tolerance was right off the bed, it did click, but after I kept spinning it around,
All right, we'll give a shout out to the designer, the creator
look
of
at
this
how
lovely
beautiful
design.
this other top looks like.
Yeah,
I should have printed that one instead. That other top, which I still could. It should fit on the that
So you
same
found
base.
something. This is by MazAndAttero, aka Rose Moore. Shout out to Rose for putting this together.
Oh man, I wish that
Here
the
is-
picture's loaded on there, but here you go. This result with regular filament still looks
This
fantastic.
is Rose's mate prints. So you can see here really nice filament there, nice pinks. You can add, you can adornish it with some more things. And Rose put together a nice CAD video on
Excellent
how to put it together.
Fusion 360 video on how
run
to
through
use
it.
the sculpting tools to model out all of the petals. And I definitely got to go back and watch
it
this
too,
because this
I
is
need to relearn how to. Oh,
should be
I
some
love
really
the
good tips.
subdivisions. Yeah, that's great.
stuff like this that I was starting to go into Blender, but
What
then
a
you
great
see
project to learn how to really fine tune the sculpt tools. It can be a little bit challenging. I always chicken out when I
well, the main thing for
when I
me,
need to
maybe
get
they
out.
fixed it, was when you're sculpting stuff and there's like no timeline, so you mess up, you gotta start all over again.
Mm-hmm. Cool.
But nice
All right,
little
well, shout out to Rose.
walkthrough on
What a lovely-
setting that up.
Lovely project. Yeah.
How good that looks.
Really great, yeah.
This is excellent.
Sweet.
Oh, there's how you can set it up with a ring, so you can have. I think that's what it's for, to fit a ring box on the inside with
Yeah.
little whatever those things are to hold the ring in the center.
Sweet.
That looks so beautiful.
Yeah, that's really beautiful. Cool. So you can get you can print your own, and shout out to Rose.
Yeah, no, I was gonna release it Monday or whatever, whenever Valentine's was.
Yeah,
Monday,
Monday.
right? 14th.
Yeah, it's Monday.
But it was like then I'll be off schedule and whatnot. But there you go. You can save it for
it's
birthday.
Valentine's week.
Mother's Day is
Sorry,
coming up.
Yeah, Mother's Day would be cool.
There you go.
Get your mother a fun quantum
So
printed
cool.
thing. Oh, it just prints. It just catches itself here.
Mm-hmm. Yeah.
Sweet.
No supports.
Very, very sweet. Yeah, you just print it like that.
Fantastic.
Yeah. These are special limited edition pins for AdaBox users. So if you have one, you got the only one in the world. It's kind of we're never gonna make these
a lot
again.
of things are turning out, unfortunately.
Here's your NFT. Nice freaking T. I don't know. I'm bad at names.
How good that looks.
Like I should have came up with like a cool name for the Zoetrope, but I got nothing. Sorry.
Trying to show the side of it.
Yeah,
it looks so
great.
good with
It
all the
looks
petals
really good.
flaring up.
Wow.
And that's this week's
Community
super
makes.
awesome Timelapse Tuesday.
We got some more community makes that we're gonna run through because we gotta do the thing where we eat food. This one just came on right before the show. Huge shout out to Remy and Todd.
Oh, this looks so good.
Todd Bot. He has been doing some very fun, very cool musical sample-based stuff in CircuitPython, so you can kind of create a sampler. You can kind of trigger different samples together at the same time. And Remy, who built our Raspberry Pi Pico MIDI fighter project, remixed it and kind of wrote an example sketch that kind of does it, but with the hardware here for the Pico. So this is not MIDI. This is playing real audio samples. Okay, like now you're understanding, right? Like this is playing.
Wow.
That's why there is a audio jack coming out.
That's what that is.
Because there's literally samples on the board, that's crazy. And it's very, very good. Like mixing the sounds and like low latency is key, and it sounds really great. So I want to play with this.
I was gonna say,
this is super dope.
you need to make like a mount on there for one of our TRS jacks, huh?
So
Plug it in right into the side.
It up. I also want to play with Remy's. He made his own features to the original Pico MIDI project as well, where you can like save some of your mappings, which is super cool. And that just really shows how CircuitPython is so capable these days. So huge shout out to Remy for sharing,
awesome.
and of course Todd Bot too for doing so many cool things in CircuitPython in the community.
Should be Audio Bot.
He kind of
Todd Audio Bot.
And here's Todd's because I just have to play it. Like I love the almond. I am a huge drum and bass fan. Like he's playing the almond. Like that is the most like historical like sample you could play is the flippin' almond.
Almond Brothers.
Yeah, man, the Almond Brothers right here. So huge shout out to them both.
I'm gonna get.
He has one where he's like actually doing it too.
Oh wow!
So huge shout out to everybody. All right, and that's the MIDI fighter. All right, we got another one here. This is a mag tag case make. I am okay with that. Thinix posted up their make of the 3D printed case for the mag tag. That's that Internet of Things e-ink display from Adafruit.
Hey.
And it says dirty.
I'm guessing that's for the dishwasher.
Yeah, I guess the dishwasher's dirty. So 30 dishes rather. But yeah, very cool. I'm glad the case works out. You can snap fit it. You can prop it up on your magnetic surface. It's all good. It says easy to print, fits together wonderfully. Guide mentions using the stand fit battery. I used the M3 standoffs instead. Very, very good. Very nice. All right, got another one here. It's a bit of a kind of a tool thing. If you ever have a tripod adapter, if you ever have like a camera and you want to use a mic stand, you can use this little adapter that I made a couple years ago. So Dad and Fintium on Thingiverse posted up their make. So this little 3D printed adapter takes the threading from a traditional microphone stand and allows you to put a 1/4-20 screw. That's the standard thread size for a camera. Looks like Dad and Fintium here kind of made it so it just kind of press fits into their Logitech 270. So that's really cool to see. Yeah, it's really cool. I like using my mic stand too to be a tripod.
Which is, I think it's 5 1/4 to.
Yeah, I think it's 5 1/4, 5/8, something like that. Here's our make of it. I forget what I designed it in, but it was pretty much to do an overhead camera. It's just like this little thing. You would put a D-ring through it, but you can remix it to like go right into it because I think the Logitech webcam he had didn't have a tripod screw. So he made it work, so you don't need one. So that's cool to see folks making their own remixes. All right, and then second to the last one. This is really cool. Really appreciate this one. We like doing a lot of 3D printed props, and we tend to put electronics in them. But you don't always have to go the whole route and like put electronics in it. So Kaylee89 on Thingiverse made the Halo energy sword and then just weathered the blade so it looks cool. So you don't need electronics and just snap fits together. It's all hollow and nice and lightweight, so you can swing it around probably. But yeah, it's cool. The blades, a couple different parts you can print.
I used the sculpting tool to create the handle.
Yeah, that was great. So
I
there's
think
no
that was the
life, but the
first
indecent.
thing.
Oh, they're iridescent colors, so you get that cool look at it. Printed at 80%, so scale down a little bit. And would you know, the printer they use is a cruelty ender. It's like, time and time again, I just keep seeing.
That's what made us
get one.
Yeah.
Because like all the makes that we're seeing are people.
Because then it's like, oh, all of our tolerance will work with everyone else.
Correct. Yeah, that's another good point. All right, and the last one for this segment. I don't know what it was. What is it? It's a Pi Zero stand. Because they're very useful. So Tico Ping on Thingiverse posted up their make of the Pi Zero stand. Very nice. Little still pre-printed stand that you can make.
I like that sparkly filament.
I like the sparkly filament too. It really pops. Very cool. And okay, again, printed on under. Is it like the default printer that when you post to make?
I mean,
again,
the quality speaks for itself. Or the usability too. I mean.
So cool. That is this week's Community Makes. Thank you everybody for posting up their makes. Really appreciate folks sharing their stuff with us. All right, folks. If you have any other questions, comments, drop them down. We're going to close up the show. We're on overtime now.
Whoops.
Yeah. We gotta go. But don't go anywhere tonight. We have a special show and tell hosted by JP.
Woohoo.
John Park is hosting it tonight. Can't wait to show him Zoetrope stuff. Zoetrope. And the show and tell. It's tonight.
Right after
that is Ask an Engineer, Lamar and Phil. Full hour of open source hardware news, top secret stuff. Is it Ion MPI?
Yes.
Yeah, Ion MPI. And new products, of course. Then John Parker will be doing a show on Thursday, every Thursday at 4 p.m. Eastern Time. Deep Dive with Scott, every Friday, 2 p.m. Pacific, or 5 p.m. I was about to say electric.
Eastern. And I think it's already announced. I think Foamy Guy will be taking over, in about a month or 3 weeks.
Spoil it. I don't know if we're spoiling it. We need to make Foamy Guy
I thought he already talked
special.
about it.
All right. And then on Sundays is From the Desk of Lady Ada live streams, where she does this special segment, The Great Search with Dizuki.
Yes.
Yeah.
Wrapping around to the start of the weekend.
Yeah, Mondays is CircuitPython meeting time. This is a great opportunity to tune in to the CircuitPython devs and community, find out what's going on every Monday at 2 p.m. Eastern Time.
Which Foamy Guy said, yes, it's already public, no worries. And he hosted it last week or this week.
Oh, I'm sorry. I got to rewatch it. Cool. All right, folks.
Taking the reins, yes.
Yeah.
What we like to hear.
That's great.
Expanding the network of our shows.
That's great. And then Tuesdays, very special product picks of the week.
You have to tune in live to get that 50% off, so make sure.
And to see that fantastic thumbnail.
I love that
cereal thumbnail. He was so proud of it too. He posted it on Facebook. I was like, yes. So shout out to JP.
The face made it.
His picks are always the best. This week he made his own Arduino on a breadboard. That's crazy. It's like 30 years later, I got my Arduino on a breadboard. That's super cool.
And then wraps around Wednesdays, starts off with
lots of shows on Wednesdays, at least 3. I don't have a banner, but yesterday, I think you probably saw it, folks.
Yes.
Super cool interview with Pyromony and Lamar.
Yep, Paul and Lamar were on there chatting up.
Lady Ada. Lady
Ada. No, it's Ada. I think we did that mistake when we first started too.
Becky was like, no.
Adafruit.
It's Adafruit. You can say however you want. We're not. I keep saying Zoetrope. It's Zoetrope. All right. Well, thank you, Esther, for your time. Thank you, everybody, for your time hanging out with us. This is why we do it. Hope you're inspired. Because I am. I'm inspired to come on and see what everybody's doing. Good luck with all your maker endeavors.
Until then, make sure to make a great day. See you later tonight.
Bye, folks.